start করো। Hello.
Yes,
Hello.
sir. Yes,
Hello.
sir.
Saurabh. Okay, very good. So I'm audible, na? You can hear me.
Yes, sir. I can hear you.
You can hear me. No problem. Fine.
Yes, sir. No problem.
Okay, okay. Now see, Saurabh, last day we have discussed about the dimension and units, isn't it?
Yes, sir.
Yeah. So it is clear, na, Saurabh?
Yes, sir. Yes, it's clear, sir.
Very good. Fine. Very good. Okay. Take. So now see, actually speaking, just we are going to discuss one thing that today we are going to discuss. Whenever we are going to use our measurement process, because in physics we are going to measure something, we have to
Yes, sir.
measure, we have to do some experiment, we have to get the result, and therefore whenever we are just measuring some thing in our experiment, so what the thing is going to happen, many times we have observed that some error is going to occur. Have you
Yes.
just we just experienced, just like I gave you a certain length of certain amount, anything, we have to measure the length of that thing. Most of the time I see that some error is going to occur, still that scale is very accurate with which we are going to measure, but still possibility is there some error occurs, because whenever just we're going to measure some error, there is a possibilities there, possibilities there, definitely. That's why, so how to just analyze that what amount of error is possible, what amount of error, whenever I'm going to do the measurement, what amount of error is possible. Okay, just like see, uh, so error, sort of, you see, error
Yes.
analysis. So just like see, suppose, Saurabh, have you seen that instrument, measuring instrument or measuring device what we use in our daily life? Huh?
Yes, I
Weight
have seen.
measuring device. Whenever we go to a grocery shop, they put over a digital weight machine, and that weight machine shows that weight. Suppose 2 gram, 2 kg, 50 gram, 2.50. This shows on the display. Huh?
Yes, sir.
In the grocery shop, we have seen that thing. Okay. So this is the thing, whenever I'm just going to see a instrument which is measuring, instrument which is going to measure something, suppose it is going to measure a mass, calibration is important. Calibration of an instrument is very much important. So what is this calibration is? You have to understand what the calibration is. Calibration means, sure of you understand, just like try to understand that a instrument, one instrument, if it is a calibrated properly, money, in just like a weight machine which is measuring the weight, if instrument understand 1 kg means 1 kg, 1 kg means 1 kg, if the instrument is not properly calibrated, if the
Yes.
instrument is not properly calibrated, suppose I'm going to think that instrument just thinking, but the calibration process is such that instrument thinking that by instrument just measuring 1 kg means 990 gram, 10 gram less. Instrument what is doing? He's measuring 1 kg equivalent to 990 gram. So every time when the customer is going to buy 1 kg amount of thing, the instrument will give 990 gram, 10 gram less it will give, isn't it?
Yes, sir.
So it is a problem for the instrument. But an instrument is giving error. But an instrument is not properly calibrated. Understanding my point? So the customer will have the loss. He is going to suffer the loss. Understanding? Huh? So
Yes.
to solve this problem, the instrumentation calibration, instruments calibration is most important. The instrument should understand 1 kg means 1 kg. He has to measure properly. Just like, see, bottling plant. Have you just heard a bottling plant where some Coca-Cola or drinks are bottled? So
Yes, sir.
suppose in the bottle it is written 250 milligram. 250 milligram it is written, and inside that bottle 250 milligram liquid is poured. Okay, but if the instrument is not properly calibrated, suppose instrument which is just giving that liquid inside the bottle, it understand instead of 250 it is giving 244 or 245, instead of 250 245. So what the thing is going to happen, every time it is giving 5 gram less, so customer is will become angry. Understanding my point? Or if the instrument, it is also possible that if the instrument is not properly calibrated, instead of 250 the instrument is giving 255 gram, 255 milligram, suppose, whatever. So it is giving extra, the company will lose, because whenever extra amount is going to the customer, company is not getting money, so company will have the loss. So this
Yes, sir.
problem arises. This is called instrumental error. Understanding my point? Instrumental error. So whenever we are going to do the measurement with some instrument, if the instrument is not properly calibrated, immediately instrumental error arises. Understood? First point.
Yes, I got it.
Achha, very good. Achha, Ayush Deshmukh. Ayush, can you hear me? Am I audible, Ayush?
Yes, sir.
Okay, very good. So today we are discussing about the error analysis. Error. Whenever in physics we do lot of measurement. So whenever the measurement is we are going to do the measurement, we use some instruments, or lot of scales we use. So there error is possible. So the how to just we can calculate the error part, that the discussions we are doing. The first thing we have discussed, instrumental error. Okay. So this instrumental error can be handled properly if we just calibrate the instrument properly. Instrument should understand, suppose 1 kg means 1 kg, not 1.5 kg. That we can do properly. We can calibrate the instrument, we can eliminate that error. Okay. Sometimes personal error arises. Instrumental error to first condition, sometimes personal error arises. Personal error. So how the personal error is possible? Just like suppose I have given a person a thermometer. So if a person is not trained properly, he don't know how to use the thermometer. Suppose a boy having fever, and the person is going to measure the fever. Okay, that person is does not know how to use that instrument properly, he cannot you cannot get the proper result. You cannot get the, suppose that person take that thermometer and touch in the hand of the boy. No. He will not get the proper reading. Understanding my point? So that is the personal problem, personal error. But if a nurse comes, immediately nurse comes and take the thermometer and put inside the mouth, then she can get a proper reading, what the fever is actually, what the temperature is. So that is also cause that due to the personal error, some problem arises, the wrong reading arises. Understanding my point? Wrong reading arises. Similarly, many times we see that parallax error. Suppose parallax error means Suppose whenever I'm just observing something, suppose I have a scale like this kind of shape, like this are the scale. So this is the scale, and if I'm going to measure with the scale, if I'm not observing vertically, just like this is my watch, I'm not observing vertically, I'm just inclined way observing in an inclined manner, then I cannot see the where the position of the clock hands are existing properly. The error is possible. So in that condition, the error is possible. So these are the situations where we can get some error. So, but this error, just like instrumental error, calibration problem, personal error, these are the problems. These are the error through which we have by experimental wrong procedure. These are the process. These are the some conditions where error arises. But this error can be eliminated if I just rectify that condition. If the method of measurement is get rectified, but if the instrument is get properly calibrated, then this kind of problem can be eliminated. Simple thing. Okay. But one another type of error can possible, which is called random error. Random. Just like random error money, suddenly error is going to come. Suddenly, without any prediction. Without any prediction. Just like suppose I am just measuring some current in a circuit. And the power supply what we have used, which is connected through our 220 voltage line, CSC line, 220 line we have just connected. But sometimes what happens, voltage fluctuates na. Have you ever seen fluctuation of the voltage? The bulb little bit glows extra and then reduces its brightness.
Yes, sir, I have.
This thing arises sometimes. Suddenly voltage becomes high. This is possible. So this is this kind of a condition when comes now, we cannot predict that condition, when the voltage will come, when the extra current will come, and our reading, what the experiment we were doing, electrical experiment suppose what we were doing, so we will get a wrong result because due to this extra current and voltage. It is possible that. So this is called random error. So we cannot predict, but actually for the random error, we cannot take precaution properly. We can take protection. We can take protection. The extra voltage cannot damage our instrument. But reading in the whenever what amount of reading we are taking, there is a possibility that wrong reading will come due to this extra voltage and current. So that is a random error. This is a special type of error. Okay. So now you see, whatever we have discussed, this kind of problem. So now see, whenever we are measuring something, we are going to get the data. I'm measuring and giving the results. This. Suppose any experiment have n number of observation. First observation giving me suppose A1, second observation A2, third observation A3, n observation AN. Ayush, understanding now? So this is the n observation of an experiment. N number of observation I have taken. Okay. Take. Now, I don't know which one is accurate by absolute value, because every experimental result is separate. Suppose I told you, Saurav, you measure the length of this room. You measure the length of the room. You measured 10 meter, 10.2 meter. Next result, you got 10.03 meter. Okay. Third, you got 10.1 meter. In this way, every time I'm observing that little bit difference is going to come. Every observation.
Okay, sir.
So this happens practically. This happens. Just we can see there's some amount of this and that plus minus occurs. Okay. So similarly, just in this way, we are seeing that the A1, A2, A3 in this way, some observation up to n number of observations we have taken. But we don't know which one is accurate value. We don't know. Okay. So what to do? Ayush, if I want to get the accurate by absolute value, this is called absolute, accurate by absolute value. So if I want to get the absolute value, what to do? Ayush or Saurabh, how you can just analyze this? Sir, this is the method we can apply, and motamoti we can get a absolute by accurate value. Any idea?
Sir, we can get the average
Yes,
for arithmetic.
right. Very good. We can get the average, right? So we are going to use the average method, the statistical method. So we are going to do the average A bar. So how can I write? A1 plus A2 plus A3 plus dot 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 AN divided by N. Bas. So now, since we don't know what is the accurate absolute value, motamoti we are now taking this one as our accurate but absolute value. Okay, no problem. Any problem? No problem. Okay. Now see, since this is A bar is my absolute by accurate value. We are assuming, but you can see that A1 is not equal to A dashed, with this average. A1 or A dashed have a separate value. A2, A dashed, average have a separate. Both are different. A3, A dashed, separate. Up to AN, A dashed, separate. Isn't it? They have some difference.
Yes.
Understanding my point? Understanding my point?
Yes, sir.
So therefore, we can tell error. There is an error. So how can I calculate this error? Just like, so first of all, the error in the first one, delta A1, what we can write? You can see what we can write? A1 minus A bar. This is the difference. Second error, difference, delta A2. Why delta? Delta means change. That's why. A2 minus A bar. So in this way, I can get the values of the error. So dot 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 delta AN. So what we can write? AN minus A bar. So these are the delta A1, delta A2 dot 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 delta AN. We are going to get these are the errors. Clear? Clear? Very good. Suppose I'm going to give a simple example. Just like see, I have measured some experiment. I have got the data. I'm writing the values of the data. Suppose 10, 15, 20, and 25, 30. 5 is there. 5 measurement. Any measurement, I've got this 5 data. Okay. So what is the average? 10 plus 15, 25, 25, 25, 50. 50 plus 31, 80. 80 plus 21, 100. If I just simply add, what I'm going to get? Summation 100, isn't it? 100 divided by how many quantities? 1, 2, 3, 4, 5. 5. So what the thing is going to come? 20. So average value is 20. Saurabh, average value 20. This is A bar. So this is A1, this is A2, this is A3, this is A4, this is A5. ठीक है? All these things. So A bar is this much, 20. You can see this 20 and 10 having a difference, 20 and 15 having a difference, 20, 20, same, 20, 25 having a difference, 20, 30 having a difference. Isn't it? So now if I want to get this one, delta A1. So for the first one, delta A1, suppose I'm just going to practically just going to see the 10 minus 20, what the thing is going to come? Minus 10, isn't it?
Yes,
isn't
sir.
it? delta A2. Everyone understanding, children? You understanding
Yes, sir.
now? Hello?
Yes, sir.
If still having problem, immediately ask me. Ayush
No.
understanding? Ayush?
Yes, sir.
Okay, fine, very good. So now we are subtracting this one. The next error, 15 minus 20. 15 minus 20. What the thing is going to call? Minus 5. Then 20 minus 20. 20 minus 20. This is 0. No problem. Then, then 25 minus 20. This is plus 5. Then 30 minus 20. This is plus 10. This is a plus 5. This is a plus 10. So what the thing is that? If I going to see delta A1, delta A2, delta A3, delta A4, delta A5, if I observe this thing, some of the values are negative, some of the values are positive. Okay. Some values are just like, see, delta A1, delta A2, dot, 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 up to delta N. Some of the values are positive. I don't know what is the thing is going to happen here. Which one is positive, which one is negative. That here I don't know. But in the practical example, we can observe some of the thing is positive, some of the thing is negative. Okay. But if I just simply add all this thing, all the errors, if I add, what the result I will get? I will get 0.
Yes, sir.
Understanding now? So
Yes, sir.
now, if I want to get the absolute error, simply try to understand. I want to get the absolute error. Then what to do? Then just like previously, for absolute value, we have taken the average of all the data. Similarly, here also, we will take the average of all the errors. But if I for averaging, if I add all these things, I will get 0. Just we have seen that. So what to do? We are going to take the mod. Saurabh and Ayush, you know what is mod? Mod, you know?
Sir, negative or positive symbol?
Mane just positive value. Just like if I take mod of plus 10. Mod, we write like this way. In this just 2 lines, we are writing. So this is 10. And minus 10, this is also 10. Understanding my point? Mod means just magnitude, the value.
Okay, got it.
Understood now? So now, whenever I'm going to take the mod of each and every one, I'm going to take the mod of each and every one. Each and every one is going to become positive. Clear? So when all these things are going to become positive, then naturally, we can take the average. Then the summation will not become 0. Is it clear or not clear? Is it clear?
Clear.
Therefore, delta A bar, mane absolute error. Just in the side, you write absolute error. Absolute error means mod of A1 delta A2 mod dot delta AN mod divided by n. ठीक?
Yes, sir.
This is called absolute error. Where we have taken the average as our absolute value. Is it clear, children?
Yes, sir.
What is absolute error? Is it clear?
Yes, sir.
Everyone clear? Ayush clear? Saurabh clear? Any problem up to this one? No problem. Check.
No, sir.
Fine. Very good. Now, whenever we in this way, this is the method. If numericals comes, you have to just do this process. Sometimes numericals gives. This is the way. Just first take the average, then you take the this errors, take the mod, and again take the average of the mods. You will get the absolute error. Now you see, we will take the another thing that is called relative error. Relative mane delta A bar by A bar. because this is my error and this is my absolute value. This is absolute error divided by absolute value. This ratio is called relative error. Okay, and if I just multiply with 100, then it is called percentage.
Yes, sir.
This is called percentage error. Simply delta a bar by a bar into 100, it is called percentage error. Okay, so this is my absolute value, this is my absolute error, this is the relative error, and with the relative error, if I multiply 100, we will get the percentage. We will tell the percentage error. Up to this point, children, any question is there?
No, sir, no question.
Understood now?
Yes, sir.
This part, very good, very nice. Achha, still, if you have any confusion, you can ask me later, no problem. Or now you can also ask me, no problem. Okay, fine, very good. So now see, so we have seen that what is the error? How can I just find this errors? Now, just like I'm going to change the page. Okay. Now see, suppose there is a variable there, z. Z is a variable. Z can be written as x plus y. Y and x are also variables. Okay. So now, suppose I'm going to tell that x, whenever I'm going to measure the x, there is an error is possible. Possibility is there. Okay. Then I can write x plus minus delta x. In this way we can write. There's a possibility also. This is a delta x amount error. Can be, it's possible. Plus y, there is a possibility is there. Delta y. So z, delta z, isn't it? তার মানে we can write like this way, z plus minus delta z x plus y, then plus minus we can write delta x plus. Therefore we can write like this way, delta z is equal to delta x plus delta y. মানে just simply remember that what amount of change in x and what মানে change মানে error, what amount change বা error in y, this has to be added. Complete. I will get the total change in z. Understanding my point or not?
Yes, I got it.
It is clear now? Simply,
Yes, sir.
suppose just like see, I told you Saurabh and Ayush measure the half of the perimeter. Measure the half of the perimeter of a rectangle. Half of the perimeter. So how can I get the half of the perimeter? If the length is L and breadth is B, because we know this rectangle perimeter is 2 into length plus breadth. তাহলে half of the perimeter, suppose P, we can write length plus breadth, isn't it? Tick.
Yes, sir.
Now length, it is called that 2 meter plus minus 0.1. Okay, and B 1 meter plus minus, here is also 0.1. The possibilities of error is 0.1. Then what is the total error is possible? Delta P, we can write delta L plus delta B, isn't it? So what is the delta L? This is 0.1, 0.1 plus this is This is also the 0.1 minus 0.1. So the possibility of error in the half of the perimeter, it should be 0.2 meter. Whenever I'm just going to measure the half of the perimeter of a rectangle, in this situation we will get what is the total amount of the error is going to exist. Absolute error 0.2. Plus minus you can write. That you can write plus minus, either positive, either negative. Is it clear or not clear? Clear?
Yes.
Very good. So now I'm going to change the page, okay? Or that I'm reducing this one. Now see, suppose any expression z is equal to x minus y. X minus y. Okay? Simple. Then what to do? If I'm going to take this one, x plus minus delta x, okay, minus y plus minus delta y, z plus minus delta z, then how to do? You can see z plus minus delta z means x. Now this is minus y, x minus y, then plus minus delta x, and this one minus plus delta y, isn't it? If I just going to put this negative sign here, this plus will become minus and minus will become plus. This part. So now this x minus y and z, they are to equal. No problem. They are equal. Now if I'm going to see that, which one I'm going to choose, because when I'm going to choose the positive delta x plus delta x, if in that situation, if I choose minus delta y, try to understand. From here, in the change of x, I have taken the positive increment of the x, delta x, and here minus delta y, I mean a decrement. So if these two are equal, suppose, they will cancel out. Understanding my point or not?
Yes, sir. Understand.
Are you also understanding now? So in that situation, if I take this one plus, this one minus, they will cancel out. That's why what to do from here, we are going to take not this minus, we will take this plus also for the delta y. That's why we can write delta x plus delta y, because this x minus y, this x minus y cancelling out. So maximum possible error in the z, that should be also z is equal to this one. This is also simply addition. Try to understand, children.
Okay.
If z is equal to x plus y, very good. If z is equal to x minus y, then also the error, maximum possible error, is equal to addition of these two. Bas, simple. Clear or not clear?
Yes, sir. It's clear.
It is clear. I think it is clear.
Yes.
Okay, very good. For both the cases, x plus y, x minus y, the change by error should be this addition of delta x and delta y. Take. Very good. Okay. Well, if you have any confusion, you can ask me now. Okay. Can I change the page?
Sure, sir. You can.
Okay. Ayush understood. Saurav understood. Very good. Okay. Now see here what the thing is going to happen here. Like suppose you just think that up to this point we have seen that x plus y, x minus y. It is possible that z is equal to x into y. X into y, z is equal to x into y. Okay, multiplication. So therefore now you can see z, whenever error is going to occur, delta z, x plus delta x, y plus delta y, isn't it? Understanding? Now z plus delta z. So multiply xy, x delta y, then this one y delta x plus delta x into delta y. This is the expression after multiplication, isn't it?
Yes, sir.
So z plus delta z is equal to xy. Now see, z already into x into y, so this one cancelling, so we can write delta z, because z and xy both sides same, so they are cancelling. So delta z is equal to x delta y delta x plus delta x into delta y. This is the thing. Tick, no problem. Now see what the thing is going to happen from here. You can observe that this is delta z. Okay, fine. X delta y, y delta x, very good. Now you observe this one, delta x delta y. Delta x means what? A small fraction of x, isn't it? What delta x is the error, small amount of error which is going to exist in the x. Similarly, delta y is a small fraction of the y which is going to exist in the measurement. So actually this is a fractional part of the x and y. Delta x is a fractional part of the x, delta y is a fractional part of the y, isn't
Yes.
it or not? Saurabh?
Yes, sir. Got it, sir.
Definitely. Are you understanding now? This
Yes,
delta
sir.
x is a small fractional part of the x, delta y is a small fractional part of the y. Suppose two fractions, suppose I'm just going to tell that one fraction is 1/3, one fraction is 1/4. Suppose I'm doing it. So if I multiply these two, what the result is going to be? 1/12, na? Okay.
Yes, sir.
So you can compare these two. Whenever two fractional small numbers is get multiplied, value is going to get reduced more. Suppose I am telling that 1/10 into 1/100. What the result is going to come? 1/1000, na? So 1/10 is a fraction, 1/100 is a fraction. If these two are multiplied, so this total thing is going to reduce more and more. Two small numbers, two fractional number, when multiplied, the value gets reduced more.
Okay, sir.
वैल्यू
Got it.
कम हो जाता है दोनों फ्रैक्शन के मल्टीप्लिकेशन होने से. Is it clear or not clear?
Yes, sir. It's clear.
Understanding my point now?
Yes, sir.
Yes, sir.
Okay, very good. So whenever this small two portions get multiplied, their value is almost negligible because the values are reducing due to this multiplication. Values just 1/10, 1/100, 1/1000 is coming. So since this portion is a negligible with respect to x and y, whatever the values of the x and y are existing, this multiplication, whenever it is the values gets reduced far, so this portion is negligible. That's why we are not just going to take this one into calculation. So we can just eliminate this part. We are just not taking these things in the calculation. I think you understood, children. Is it clear?
Yes, sir. Understood.
Yes, sir.
Yes, very good. So therefore, delta z now, just we are going to take this one, x delta y plus y delta x. Bas. Therefore, now what the thing is going to happen? Delta z, now we want to get the relative error, mane ratio. Delta z by z is equal to x delta y plus y delta x divided by z divided by z. Okay. So therefore, delta z by z is equal to x into delta y divided by z one x into y plus y delta x, z মানে x into y. Therefore, this x cancelling out, y cancelling out. So finally, what the result is going to come? Delta z by z is equal to delta y by y plus delta x divided by x. Children understanding my point or not?
Got it, sir.
Understanding now? Very good. So therefore, finally, we can conclude that. Delta z by z into 100, delta y by y into 100 plus delta x by x into 100. So this is this up to this portion, this is a relative error, and this portion percentage error. This portion percentage error. Therefore, suppose if I am going to tell that, Saurabh, x has a error 1%. X has what amount of error? 1%. Check. Y has a error 1.5%. Okay. So what should be the error in the Z? 1.5 plus 1, because this is the percentage error in the y, this is the percentage error in the x. So x we know 1%, y we know 1.5%. So z mane the error in the z, it should be 2.5% error.
Yes, I got it.
Understood?
Yes, sir, understood.
Very good. So simply just add these percentages. If the multiplication is existing now, simply add the percentage, but nothing else, nothing extra. Okay. Any question up to here?
No.
Very good. Ayush understood? Saurabh understood? No problem.
Yes, sir.
Very good. So now just record. This is a 2.5% error in this situation. So now just like see, if I can I go to the next page? I'm going to the next page.
Yes,
okay?
sir, you can.
Acha, Saurabh, tell me though, y is equal to x square. Y is equal to x square. Check. Okay. X has the 2% error. What should be the error in the y?
Root 2.
Root 2.
Root 2%. That means root 2 by 100.
Listen. Okay, listen. You can see y means x into x. So then in the previous case, what we have seen?
Yes, sir.
Not y. I'm going to take the z because we have taken the z. Let's take the z. Okay. In the previous case, we have taken z is equal to x dot y, x into y. Then we write delta z by z is equal to delta x by x plus delta y by y. This we have written though. Just like in a similar manner, you can see z is equal to x into x. So can't I write delta z by z? Instead of this x, we can write delta x by x plus, and this was y. So this is x here because x square, delta x by x. Okay. Understanding? Therefore, we can write delta z by z into 100 is equal to 2 into delta x by x into 100. Because there is a 2. 2 is existing, power is 2.
Yes.
Is it clear or not clear?
Clear.
Clear? So therefore now this part is a 2%. So z is having percentage error 2 into 2, 4% error in the z.
Okay.
Clear or not clear?
Yes.
Clear? Very good. So now if it is given z is equal to x to the power 3 by 2, suppose x to the power 3 by 2. X has a percentage error 2%. So what should be the result? What is the power? 3 by 2. What is the power here? 2. So that 2 is multiplied with the percentage error.
Yes.
2 is multiplied with the percentage error. 2 is the power multiplied by the percentage error. Simple thing. So similarly, here is the power is 3 by 2. Therefore, in this condition, 3 by 2 into, let us think the percentage is same, 2% into 2. Understanding my point?
Understand.
2 cancels out, 3% error. 3% error.
Okay, sir. Got it.
Understood properly. Check, no
Yes.
problem. Any problem?
No, sir. No problem.
Very good. Very good.
No, sir.
Very good. So simply the rule is that you observe the power. What the power is existing, you observe the percentage. Suppose z is equal to x to the power n. Power is n. N can be any value. Then suppose x has a percentage, anything, anyway, suppose percentage 2%, suppose in the previous one. So z will be n into 2% error. Bas. Just remember this thing. Z is equal to x to the power n. Okay. So now, is it clear? I think it is clear. No problem.
Yes, sir. It's clear.
Can I change the page?
Sure, sir. You.
Huh?
Sure, sir. You can.
Okay. If you're writing, then tell me. If you're copying,
No, sir. It's called noted already when you are writing.
copying completed, na? Very good. You try to copy. Huh? Okay. Now see, if I'm going to tell that z is equal to x square y cube p to the power 1/4, like this one. Simple, very simple. X has a percentage error 1%, y has a percentage error 2%, and p has a percentage error 4%. Okay, you have to find the percentage error in the z. Okay, so how can I get? Well, delta z by z is equal to, what is the power of x? 2. Delta x by x. What is the power of y? 3. Delta y by y. What is the power of p? 1/4. Delta p by p. Understanding, children? Understanding my point?
Yes, sir.
Whatever may be the number of multiplication of the variables, it can exist there. No problem. Just like instead of x, it is x square. So 2 is coming, delta x by x. Children? Hello?
Yes, sir.
Is it confusing?
No, sir.
Very simple, just like see, the power of y 3, delta y by y, power of p 1/4, delta p by p. Bas, complete. Now you can see delta z by z into 100, just like if you convert into 100 percentage. What is the delta x by x into 100? 1%. Okay, 3 percentage error 2 into 2 plus 1/4 percentage error 4 into 4. So therefore 2 plus 3 plus 1, 3 to the 6, 2 to the 1, 6 plus 2 mane delta z by z into 100 mane 9%. 9% error is going to occur in the z. Understanding my point or not?
Yes, sir. Got it.
Understood? Very good.
Yes, sir.
Very good. So now the another thing, just final, this thing is a very important thing. Okay, try to understand that one. Like just we are going to see that a multiplication, x square, x into x, y to the power 3 multiplied, p to the power 1/4 multiplied. Okay, we can show that if z is equal to x by y divided, Have you started the binomial theorem? Binomial? Huh?
No, sir.
No. So you cannot understand now. By binomial theorem, in the mathematics one part is there. By binomial theorem, we can show that here also delta z by z is equal to delta x plus delta x by x plus delta y by y. So either multiplication, either division, this is going to be valid. This is valid. Try to remember.
Okay.
Just simply remember. So last one I'm going to give one question. Ayush understood na? Ayush understood? Either multiplication, either division. You are going to follow this one. Take.
Okay.
Now, just last question. Z is equal to p square x cube by y to the power half. Okay, p square x cube by y to the power half. Tell me, if p has a 1% error, x has a 2% error, and y has a 2% error, what is the final error in the z? Okay, so now delta z by z মানে power কত p 2 delta p by p plus what is the power of x 3 delta x by x plus what is the power of y half delta y by y, isn't it? So therefore delta p by p 1%, 2 into 1 plus 3 delta x by x, what is the percentage? 2% plus half, what is the percentage of y? 2%. So finally what the result is going to come? 2 plus 6 plus 1, it is also 9%. Delta z by z into 100, we are going to get the finally 9% error is going to occur in this situation if this is the question is going to we are going to have. If this is the question we are going to have, this is the procedure through which we are just going to proceed. Either multiplication, either division. Power into percentage plus power into percentage plus power into percentage. In this way, we have to add all these things. We have to simply add all these things. Children, understanding my point or not?
Yes, sir. Understood.
Okay, very good. Okay, very good. Acha, fine, just like. So now, children, see, observe that. So this is the thing. Now, I'm just going to change the page. Let us think one example. Rectangle. Okay, rectangle length is given L. 2 meter. Length is 2 meter. Error মানে chance of plus minus 1 centimeter. Okay, breadth 1.5 meter, and plus minus error plus minus 0.5 centimeter. Okay, then find the area with possibility of error. find the area with possibility of error. So what to do? I know the area mane length into breadth, that we know. Length multiplied breadth. Any problem? No.
No, sir.
Check. Very good. Now see. You can see what is the delta L? 1 centimeter. What is the L? Huh? 200 centimeter. 2 meter. 200 centimeter. Isn't it?
Yes, sir.
তাহলে delta L by L, what the thing is going to come? 1 by 200, isn't it? Into 100, if I is going to convert into percentage, into 100 মানে half, মানে 0.5 percentage error. 0.5% error is possible. Where? In the length measurement. In the length measurement, 0.5% error is possible. Children understood?
Yes, sir.
Very good. Similarly, observe breadth. Breadth 1.5 and delta B 0.5. মানে 1.5 মানে 1.5 the meter. I have to multiply. মানে 150 centimeter. And error 0.5 centimeter. Therefore, delta B by B is equal to 0.5 divided by কত? হ্যাঁ 150. So now if I just going to convert it to percentage into 100 into 100. Children understanding my point? I think you are understanding.
Yes.
This cancelling out. Then multiplied 5 by 15, isn't it? তার মানে 1 by 3, তাই তো?
Yes, sir.
হ্যাঁ,
Right.
1 by 3 মানে 0.34%. ঠিক? Understood?
Yes, sir.
So therefore, finally, total error is going to occur delta A by A is equal to delta L by L plus delta B by B. If I both side, if I multiply with 100, so finally the percentage is delta A by A into 100, that is going to become 0.5 plus কত 0.34, তাই তো?
Yes, sir.
0.34. So what the result is going to come? 0.84. This much of percentage error is possible in the area measurement. In the area measurement, 0.84% error is possible whenever we are going to calculate the area. Isn't it?
Yes, sir.
Very good. Now, see, this is the length 2 meter, this is the breadth 1.5 meter. So, how can I get the area 2 into 1.5? Isn't it? তাহলে this 3 meter square.
Yes, sir.
3 meter square. Area is 3 meter square. And what is the possible error is going to occur? Just if I just going to think that 3 meter square মানে because 1 meter মানে 100 centimeter, তাই তো? তাহলে 1 meter square মানে this much of centimeter square, isn't it? Isn't it?
Yes, sir.
So therefore, this I'm going to have 3, 1, 2, 3, 4 centimeter square. This much of centimeter square is the area. Now, if I want to get the what is the error part? So how to do? error part means 0.84% মানে into 0.84 তাই তো by 100 okay 1 হ্যাঁ তাহলে what the result is going to come হ্যাঁ 3 into 84 okay so 3 × 24 240 3 3 4 12 মানে 252 centimeter square. Have I done correctly? 3 4 12 2 হাতের নিচে 1 3 3 8 24 আর 25 হ্যাঁ 252 centimeter square. This much of possible error is possible. মানে we can write like this way: area plus minus 252 centimeter square. Children, see, is it clear or not clear?
It's clear.
So if area of this rectangular shape, if I want to calculate, then 252 centimeter square area error is possible. From here, just we found. Any confusion there?
No, sir, no confusion.
Both of you, Ayush, Saurabh, clear na? Saurabh is clear.
Yes, sir, clear.
Saurabh,
Yes, sir.
clear.
Yes, sir, it's clear.
Okay, Ayush, is it clear? So Ayush having some network problem, get disconnected. Okay, no problem. We have to see what the problem is going to arise. Whatever, no problem. Now, can I change? I'm going to change.
Yes, sir. You can.
Okay, now see. Just like see, suppose you know, in a experiment we have experiment. Suppose Saurabh, there is an experiment of the pendulum is there. Just like pendulum oscillates, and we know that time period 2 pi root L by G, whole root. The formula we know. Have you heard this formula? Because in the first day in the dimensional analysis, we proved just near to this expression, near to this. Just we try to predict by dimensional analysis. You done that class? My class you have done na?
Yes, sir, I have.
So we tried to predict because we found that T is equal to something K root over L by G. That we tried to predict like this way. Okay, whatever. That day in just in the whatever. So now in this expression, the period of the simple pendulum is like this way. We measured that a length of that pendulum is equal to 20 centimeter. We measured the length of the pendulum is 20 centimeter, and possible change in L is equal to delta L is equal to 1 millimeter. There's a possible change. Either this kind of, if I'm just going to measure that this kind of change, but error can occur. 1 millimeter. Okay. And for the 100 oscillation, and for the 100 oscillation of the pendulum, it is found 90 second. 100 oscillation, it is found 90 second. Okay. Time period measured 100 oscillation 90 second. Tick. And the maximum possible change in this measurement is 1 second. In 1 second. Okay. Then the question is telling that The question is telling that for measuring the g, acceleration due to gravity, what is the maximum possible percentage error? Is the question clear?
Yes, sir. Clear.
So for measuring the g, what is the maximum possible percentage error? Okay, so now see, if I want to measure the g, we first of all we want to measure the t, then we have to measure the length, isn't it? So now see, t is equal to 2 pi root over L by g, then square it. T square is equal to 4 pi square L by g by making the square. So now I want to find the acceleration due to gravity from this data. So acceleration due to gravity is equal to 4 pi square L divided by t square. Clear?
Clear.
No problem. Just we got a formula, expression of the acceleration due to gravity. If I put the L, if I put the time period, immediately we can just find. Okay. Now see, you can see this part, hold on, 4 pi square, it is a constant. It is a constant. It is a constant. So, just like I can write z is equal to x into y. If I write z is equal to 2x into y, okay. So, is there any change of 2?
No, sir.
No. Delta z by z is equal to delta x by x plus delta y by y. It is possible, but delta change of 2 is not possible. This is wrong. 2 will be 2. There is no chance that 2 will change. So if there is any constant is going to exist, don't do anything with this one. So directly we can write delta g by g is equal to delta L by L plus t square, mane 2 into delta t by t. This is the expression.
Yes, sir.
Understanding? No problem. Very good. Okay, now see what the thing you have to do. You can see like this one. 1 millimeter mane delta L. 20 centimeter mane 200 millimeter. Okay, so we can write like this way. 1 millimeter mane 1 by 200. Okay, into 100, because we want to get into the percentage. That's why 1 millimeter by 200 millimeter into 100. Take plus 2 into delta t by t, that is equal to delta g by g. Okay, into 100, definitely into 100. Here also into 100. We want to get the percentage. Okay, now see what the thing is going to happen. Sort of, see properly. 100 oscillation. 100 oscillation. What the time required? 90 seconds. So
Yes.
this is the total time, isn't it? What is the error possible? 1 second. Within 90 seconds, when with the clock, with the stopwatch, with which we are going to measure, we are measured, because have you seen that watch? It rotates just like a tick 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 tick. So either way, 1 second maximum plus minus possible. So that's why error maximum within 19 seconds, 1 second is possible. Understanding that?
Yes.
Understand? Yes, very good. Tale, for 100 oscillation, time is 90 and error is 1 second. But 90 seconds and 1 second. For one oscillation, what is the time? 90 by 100. And what is the error? 1 by 100.
Yes, sir.
For one oscillation, this is the time period. And within one oscillation, what is the possible error? This much of possible error. Is it clear? So that's why we can write like this way. We can write like this way. Time period is equal to 90 by 100. Okay. And change of time, error, 1 by 100. Now see, sort of. Is it clear? No problem.
Yes. Clear.
So how the delta t came? Clear. And how the t came? Clear.
Yes, sir.
Okay. Fine. So therefore 100 into delta G by G is equal to this thing is going to come 0.5. The first one, delta L by A, this much of percentage plus 2 into delta T by T. So what the thing is going to come? Delta T mane 1 by 100 and T mane 9 by 100. 90 by 100 into 100. So this part. So what the thing is going to come here? This 1 by 100, 1 by 100 cancels out. 1 by 100, 1 by 100 cancels out. What the thing is going to come? 0.5% plus 2 into 1 by 90 into 100. So
Yes.
0, 0. 2 into 10, 20. 20 by কত 9 ঠিক আছে understanding 2 into 10 20 by 9 so what the result is going to come 20 by 9 now we can add here 2 18 and the 10 2 point coming 0 now we can add here 2 and again 18 again the reckoning is going to come 2.23 2.23 okay
Okay.
তাহলে ফাইনালি 0.5 প্লাস 2.23%. তাহলে 2.23 and 0.5, so 3, 7 and 2. Finally, 2.73% error. 2.73% error for measuring the acceleration due to gravity is possible. .73% error in this situation. In this situation.
Okay, sir.
Understood. I think you understood. ঠিক? No problem.
Yes, sir. No
Very
problem.
good. Very good. Very good. Now see, just like any question?
No, sir. No problem.
No question. Very good. Now, Saurabh, see, like I'm going to give you a question. Try to copy.
Okay.
A force of 2500
Yes, sir.
plus minus 5 Newton is a force. A force. Okay.
Oh, okay.
A force this much applied over an area of 0.32 plus minus 0.02 meter square.
Okay, sir.
0.32 plus minus 0.02 meter square. This is the area. Okay.
Yes, sir.
Calculate the pressure exerted over the area. Calculate the pressure exerted over the area. So, how to do? Saurabh?
Sir, we have
Pressure,
to put the
you know, pressure?
yes, sir. Force per
Force
area.
by area, isn't it?
Yes, sir.
So, will you try a little bit? Or I will give you
Yes,
hints. Saurabh?
Yes, sir.
Pressure means force divided by area. তাই তো?
Yes, sir.
বেশ আচ্ছা তাহলে delta P by P, first of all just I'm going to find the error. So what thing is going to come? Delta F by F plus delta A by A, isn't it?
Yes, sir.
Change of pressure by pressure is equal to delta F by F plus delta A by A, na?
Yes, sir.
Right. Understanding my point? Very good. Now, what is this delta F? Saurabh?
Sir, 5.
Delta F means plus, this is a 5. And what is the F? 2500?
Yes, sir.
তাহলে 5 divided by 2500, and if I multiply it with 100 both sides, then I will get the percentage error. So I'm going to multiply it with 100. Check. So what the result is going to come? Cut. Then 1 by 5, this much of percentage. Check.
Yes, sir.
And for the area, Saurabh,
Area.
for the area,
0.02.
delta A by A. So what the thing is going to come? Delta N মানে 0.02. 0.02. Area means কত? This much.
Yes, sir.
0.32. Check.
Yes.
Into 100. We have to just do this thing. 0.02 divided by 0.32. So what the thing is going to come? মানে if I is going to multiply 0.02 into 100, so we are going to get 2. So 2 divided by 0.03, 0.32. 2 divided by 0.32, it is going to come 6.25. 6.25%.
Okay, sir.
Saurabh, is it clear or not clear?
Yes, sir. Clear, sir. Clear. Yes, sir.
Or 1 divided by 5, 0.2. This one is 0.2%. This one 0.2%. ঠিক আছে? তাহলে 6.25 plus 0.2 means 6.45 here. 0.2% plus 6.25%. So what I can get? 6.45%. So pressure is going to have 6.45% error is possible.
Okay, sir.
So therefore, from the data, what is the pressure is? What is the force? 2500. And what is the area? 0.32, isn't it?
Yes, sir.
বেশ তাহলে 2500 divided by 0.32. ঠিক?
Yes, sir.
What is coming? 7812.5. 7812.5. This much of pressure. 7812.5. This much of pressure is going to exist. ঠিক আছে?
Oh, yes, sir. Yes.
And the percentage of this one, but the percentage of 7812.5 is 6.45. তাহলে what the value will come? 7812.5 into 6.45 divided by 100.
Right. Yes, sir.
So the result is going to come 503.9. 503.9. If I just calculate this one, if 503.9, তার মানে we can write the pressure expression is equal to 7812.5 plus minus 503.9. So how this 503.9 came? The percentage of this one with 6.45. তাহলে 7812.5 into 6.45 divided by 100, I will get 503.9.
Okay, sir, got it.
So I think Saurav, you understanding, na?
Yes, sir, understood.
Very good, very good, very good. Acha, last one question I will give. Last one
Okay.
question. Just little bit try. The
Okay, sir.
question is telling that radius of curvature of a concave mirror. Radius of curvature of a concave mirror. Sure, please write.
Okay, sir, I am writing.
Radius of curvature of a concave mirror measured by a spherometer. Spherometer is an instrument
Okay, sir.
through which we can measure the radius of curvature of a
Okay, sir.
concave mirror. The radius of curvature of a concave mirror measured by a spherometer given by just like this way. R is equal to L square by 6h plus h by 2.
Okay, sir.
L is having something value and h is having something value. The value of L and h, value of L is equal to, they will inform just like 4 centimeter, and h 0.065 centimeter. This 2 is given. Value of L is equal to 4 centimeter and the h is equal to 0.065 centimeter. Okay.
Okay, sir.
And the question they are asking that L is measured in a meter scale. L is measured in a meter scale and h by spherometer. L is measured in a meter scale and h by spherometer. Find the percentage error in the R. Capital R. Find the percentage error in the capital R. This is the question.
Okay, sir.
This is H. Understood?
Understood.
So how to do? Shoda?
Yes, sir. Here it is given L square. That means first of all, we have to convert all of these into delta R by R into 100. First, we have to convert this to delta R by R into 100. Then it is given L square. That means it 2 into 4 centimeter, and it is given, it is measured in meter scale. That means we have to convert centimeter into meter.
Okay. Okay.
Then it is given H is measured in spherometer. That means 0.065. Then it will be also in the addition. Then it is given H, that will be the same value 0.065, and 2 is constant. That means we have to.
Okay. The process is okay. Okay. One thing I'm just going to tell you. You see, whenever I'm going to measure with a meter scale, 1 meter length scale,
Okay. Yes.
So in that situation, 1 meter scale is divided into 100 centimeters. So
Yes, sir.
100 centimeters.
Yes.
So what is the maximum possible error can occur? What is the maximum possible have if I just going to see 1 centimeter scale, then maximum possible in that situation can occur for 1 millimeter measurement. If I just going to see now, just meter scale, centimeter, 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 in this way 100 centimeter. In the and in a centimeter, it is also divided by 10. Millimeter is there now.
Yes, sir.
Millimeter is there. Tahale, in that situation, we can just, I'm just going to think that millimeter, which is maximum possible, 1 millimeter, which is maximum possible error in this situation.
Okay, sir.
Take na? And in the age, what is the maximum possible error is possible? Delta H 0.001, isn't it?
Yes, sir.
Because 0.0065, so least value in this situation, in this decimal point, that is the 0.001. This is the least existing here for delta H. Take. Tahole, in this condition, just like I can write this one, delta R by R is equal to is equal to 2 into delta L by L, because power of the L is 2. That's why I'm going to write 2 into delta L by L. And H is 6 is a constant. We did not require to think about the 6 plus H is the lower portion. Delta H by H, isn't it? And here also another H is there. There are X plus Y. So this I have to count. This is also delta H by H. This part, isn't it?
Yes, sir.
ठीक ना?
Yes.
So therefore, what thing is going to come? Delta R by R plus 2 into delta L by L plus 2 into delta H by H. Check. Very good. Therefore, you can see that, Saurabh.
Yes.
H, this one, H, delta H by 0.001 divided by 0.065 into 100. ঠিক না?
Yes, sir.
হ্যাঁ, তাহলে 0.001 divided by 0.065 into 100. What the result is going to come? 1.53. This is 2 into 1.53. This part. Okay. So into 2, 3.7 approximately. We just can write this one is equal to 3.07 approximately. This one, this much of percentage for the change of age, and this one for length. For length, what we can have? For the length, I'm going to see that if I'm going to take 1 millimeter, 1 millimeter, so 1 millimeter or meter, decimal centimeter, millimeter, 1 millimeter delta L. This is the delta L, 1 millimeter divided by 40 millimeter, 4 centimeter, meter, decimal centimeter, millimeter, 40 centimeter into 100. Okay, take now.
Yes, sir.
তাহলে 1 divided by 40 into 100, it is going to come 2.5%. Okay.
Okay, sir.
So this is a 2.5 plus 3.07 and 2.5, and it also have to multiply it by 2 মানে into 2 মানে 5%. 5%. So this one is 5%. তাহলে 5% plus 3.07 মানে 8.07%, মানে approximately 8%.
Yes, sir.
Sort of understood, na?
Yes, sir, got it.
So this kind of question will come. Okay, so you have to be familiar.
Yes.
With this kind of questions, you have to become familiar. Okay, and this is the thing now. So the error part, so this kind of questions, just with the percentage error, you have to do this, do all these things. Now see, Saurabh, just like we have a new thing that is called significant figure. Acha, up to error is there any question is there, Saurabh?
No, sir, no doubts.
It is clear, na?
Yes,
very
sir.
good. Now significant figure, some rules are there, Saurabh. Some rules are there, just you have to remember these things. Okay, simply you have to remember some rules. Money, whenever we measure some measurement, na, we write some data to, isn't it?
Okay, sir.
Suppose I'm writing a data 164 centimeter. I'm writing. Fine. Acha. Saurabh, if I write 164 meter, if I convert into centimeter, what I can get? 164,000 centimeter, isn't it?
Yes, sir.
Take. So from the centimeter to meter, if I just convert the unit, these two zero will be eliminated.
Yes, sir.
So these two zeros are insignificant. Try to understand my point. Understood or not understood?
Yes, sir, understood.
Any write a point. Write a point. Any number without decimal, any number without decimal, trailing zeros are insignificant. This is a number without decimal. Check.
Yes, sir.
So those are this kind of number without decimal. If the zeros are existing in the last trailing, so they are insignificant. I can drop. I have to write how many significant figure is there? 3 significant figure. 16400. How many significant figure? 3. 3 significant figure in this number. 16400. If the question is asked how many significant figures are there? 3 significant figure. 164. Is it clear?
Yes, sir, clear.
Very good. Next point. All non-zero digits are significant. Decimal can be placed anywhere. Decimal can be placed anywhere, but all non-zero digits are significant. Clear? Just like I'm writing 26445. How many significant figure? Throw
5, sir.
5. Now in this situation I can put a decimal here. 264.45. No matter. 5 significant figure. I can put a decimal here. 2.6445. No change. 5 significant figure. Okay, so all non-zero digits are significant.
Okay, sir.
Okay, very good. Third point. Zero or zeros. Zero or zeros existing in between non-zero digits. Zero or zeros existing in between non-zero digits are significant. Zero or zeros existing in between non-zero digits are significant.
Yes, sir. Noted.
Just like, see, I am writing 1.20034. How many significant? 1, 2, 3, 4, 5, 6. Decimal point can be placed anywhere. That you have to note. Decimal point can be placed anywhere, but these zeros are existing in between non-zeros, so they are significant. Clear?
Yes, sir. Clear.
Next point. Writing completed, na?
Yes, sir. Complete.
Okay. Next point. In number less than 1, number less than 1, if started after decimal, you write a number less than 1, if 0 is existing after decimal, number less than 1, if 0 is existing after decimal, those are insignificant. Those are insignificant.
0 is existing after.
Just like, see, a number less than 1 mane 0.0053. But after decimal, these are insignificant.
Okay, sir.
So how many significant figures are there?
2.
2, right? Understood?
Yes, sir.
Very good. But you have to understand, in a decimal number, in a decimal number, just like 0.00530, trailing zeros are significant.
Okay, sir.
Trailing zeros are significant. Bas. You have to remember this thing. These are insignificant. Cross. But this is we have to accept. This we have to accept.
Got it, sir.
Okay. So simply just whenever some number is given and you have to count how many significant numbers are there, how many significant figures are there, just simply you have to follow this thing. Just these are some of the rules we follow for finding significant figures. Okay.
Okay, sir.
So Saurabh, so today error analysis you have understood, and also I think significant figure, these rules are given, just you have to remember the rules, nothing else.
Okay.
So this is okay. I think it is clear to you, isn't it?
Yes, sir. It's clear.
Very good. Very good. Okay, Saurabh, so today we are going to end. Next day we will do again.
Okay, sir. Thank you.
Any questions you have, you can send to the Vidyanest. Okay.
Okay, sir.
Any confusion, just we will discuss. Okay.
Yes, sir.
Okay. Okay. Sure.
Okay, sir. Thank you.
Okay. Bye.